enhancement of the two-particle transfer cross-section, although the mechanism is a sequential transfer and not a cluster, simply cluster transfer. Let's take, for example, just as an example, just a trivial example. We make oxygen 16, oxygen 18. We took two particles from lead. We took it from the first lead pole. And then we go through oxygen 17, through the D5 half, the S1 half. And the wave function of oxygen 18, we took just a combination of D5 half square, S1 half square. And then you have to weight the two paths exactly according to the amplitude of the wave function. And the result is that if you calculate as a function of the impact parameter the probability of transferring the two particles unperturbed in the D5 half square, you get a certain result. If you take the correlated wave function, you get an enhancement of the probability, and this enhancement is just due to the Perry correlation. Now, of course, what happens when you go closer to the stability line, that's why problems start to come, because your intermediate state start to be only few intermediate states, and then you have all the continuum state. And even worse, what's happened when you go to the drip line, you say, suppose this is lithium 11, this is lithium 9, there are no bound states in lithium 10. So all the intermediate states are in the continuum. And if you want to use the same technique, you are all right in troubles. And the only thing one can think is to try to go through procedure based on discretization of the continuum. So at this point, the discretization procedure of the continuum become the main problem in this kind of reaction. Okay, so I just finished touching the problem of the discretization of the continuum, which is sooner or later some problem that any nuclear model will face when you are approaching the drip line, because all the models which are based on expansion in a certain basis, you will get problem when these available bound states are not any longer there, and the only available states are in the continuum. Okay, and there are different possibilities for diagonalizing, for discretizing the continuum. I think Mark was, for example, mentioned before, not for the continuum, but for the bound state, you just diagonalize the body with a harmonic oscillator, but you can also impose boundary condition on a big box, or you can use discretized wave function with scattering